I invite Ben Andrews to start sharing his screen while I introduce him. So thank you, Ben, for joining us. Dr. Ben Andrews is the director of the Global Volcanism Program with the Department of Mineral Sciences at the National Museum of Natural History of the Smithsonian Institution and the leader of the IAVCEI Commission on Volcanic Hazards and Risks as of very recently. His research covers volcanic processes and hazards ranging from magmatic storage and recharge conditions through eruption to deposition, rates of mass, momentum, and energy transfer in different volcanic and geologic processes, analog modeling, optical flow, velocimetry, turbulence analysis, sample grain size and component analysis, experimental petrology, electron microscopy, and crystal isotope stratigraphy. Ben, please take it away. Thank you very much for being here.
Thank you very much. Just real quick, can everyone see my screen? Okay.
Yeah, it looks great.
Very good. And my apologies for the second paragraph of that introduction. That was a lot of unnecessary information. Well, thank you all for having me here today. And I'll be speaking about some of the volcanic activity that occurred right before and then after the large earthquake that happened in Kamchatka just about, I guess, 6 months ago. So as it says here, this is Kamchatka eruptions following the 29 July magnitude 8.8 earthquake. And the picture there on the left is of Krasheninnikov erupting for the first time in about 500 years. And that picture is from August 3rd, so 3 days or 2.5 days after the big earthquake. So for a little background, Kamchatka is often called or sometimes called a land of volcanoes. And in the peninsula there's 46 different volcanoes with Holocene eruptions. And this is a huge number of volcanoes. And some of those are large caldera systems. Some of those are, there's a couple volcanic fields. And then there's stratocones such as we'll be seeing the activity from today. In any given year, about 2 to 4 of these volcanoes erupt. Of course, during this last year, it was, I think, more like 7 erupted. And as of this talk that I'm giving right now, there's 3 volcanoes currently erupting in Kamchatka. So indeed, it is a very active place. And some of the world's most active volcanoes are here in Kamchatka. As the example here, Sheveluch in the northern end of the peninsula has had 22 VEI5 or larger eruptions. Now, for the folks on the call that don't know what a VEI5 eruption is, which is totally reasonable, that's an eruption about the same size as Mount St. Helens in 1980. And so globally, the eruption of that size occurs on the order of about 1 every 10 years. And in the Holocene, we have 22 of these eruptions documented just from Sheveluch. So this is a lot of large eruptions from a single volcano. This area is monitored by primarily by two agencies. There's the Kamchatka Volcanic Eruption Response Team, or KVERT, which is based out of Petropavlovsk-Kamchatsky, which is the major city in Kamchatka down here in the southern end of the peninsula. And then we also have the Tokyo Volcanic Ash Advisory Center. And these two agencies use different or complementary ways of monitoring. So KVERT monitors using for the most part, ground-based observations, so seismology and cameras and scientists on the ground. The scientists from KVERT and also from, but more broadly, Russia have over the years put together amazing eruption histories for all these volcanoes using tephrochronology, so that even though Kamchatka is a very remote place, we have a wonderful record of its eruptions. That's why we can say Sheveluch has had 22 VEI5 eruptions in the last 10,000 years. The Tokyo Volcanic Ash Advisory Center, on the other hand, is one of nine VAACs around the world, and it has jurisdiction over responsibility for monitoring the volcanic activity in Japan and Kamchatka and Indonesia, and it does this using satellite observations. And so its mandate is that as soon as a volcano erupts, it needs to get an observation of that ash, and then a forecast where that ash is going to be so that airplanes can get out of the way. And as we'll see in the talk here, the principal hazard from the Kamchatka volcanoes and the principal hazard that occurred this last summer was ash and its threat upon aviation. And as a quick reminder, volcanic ash is not like wildfire ash or fireplace ash. That is to say, volcanic ash is not burned up stuff. It's not burned up organic matter. Instead, volcanic ash is little tiny rock particles. So little frozen bits of volcanic melt, frozen volcanic crystals, very small particles that if an airplane encounters enough of them, it tends to shoot down an airplane. And so as a result, the community, the global community, tries to make sure that airplanes know where volcanoes or where volcanic ash is, so that airplanes can get out of the way. And this is an example showing some of that. So although Kamchatka is a rather remote place, a huge amount of air traffic goes very near to the Kamchatka Peninsula. So this is a schematic map of the air routes over the North Pacific that Tina Neal and co-authors put together about 15 or 18 years ago. And we can see that there's numerous major air routes. Pretty much all North Pacific air traffic goes just to the east of Kamchatka, and the prevailing wind directions tend to blow any ash from a Kamchatkan eruption into those air routes, or in the direction of those air routes. And so it's a very important place for monitoring where the ash is going to go. All right, to set the stage for the late July earthquake. Before this earthquake happened, there were 4 volcanoes erupting, starting from the north and moving south. Sheveluch had been erupting since, well, the last about 25 years ago, so since 15 August 1999. Kluchevskoy had been erupting since April of 2025. Bezimiany had been erupting since the end of 2024, and Krymsky had been erupting also since April 2025. And because of these eruptions, the Tokyo VAC had issued numerous volcanic ash advisories, or VAAs. So we'll see an example of one of those in a minute. And then on 29 July at about 11:30 in the evening, there was a magnitude 8.8 earthquake, and activity at Kluchevskoi increased. Now, I want to note, though, that there's some confusion sometimes about whether the earthquake triggered activity at Kluchevskoi or intensified activity at Kluchevskoi, or what was going on. And this is important because at 23:50, so about 26 minutes after the large earthquake, there was an ash plume that was extending 50 kilometers to the east of Kluchevskoi. But this eruption, the explosion that was generating that ash plume, had almost certainly begun before the large earthquake. And then at 00:36 in the morning on 30 July, so about an hour after the earthquake, there was a lava flow advancing down the southwest flank of Kluchevskoi. So the earthquake had happened and the eruption was happening. The eruption had been going on beforehand, but activity at the eruption intensified at the same time as the earthquake, but very likely intensified right before the earthquake. So there's trying to unravel what triggered, whether this eruption was triggered by the earthquake is a little bit fraught, or takes more information. Now, this is an example of one of these volcanic ash advisories that the Tokyo VAC issued. This is for Kluchevskoi for August 1st of 2025, and you can see in the upper left panel, the little red symbol is the volcano, and then that black polygon is the 50-kilometer ash plume, and then, or 150-kilometer ash plume. And then we can see that this is now extending. There's a forecast in the upper right panel for 4 hours later, and then another 6 hours later, and then another forecast in the lower left panel for 12 hours after that initial observation. And so this is how the volcanic ash advisory centers disseminate the information about these ash plumes. There are scientists at those agencies, at the Tokyo VAC and other VACs, who identify the ash cloud in satellite imagery, draw a polygon around it, and then publish that and send it out so that airplanes can get out of the way. All right, so that was the earthquake had happened, and Kluchevskoi continued to erupt, and then about 2.5 days or 3.5 days afterwards, Krasheninnikov erupted at 4:50 in the afternoon, 1650 hours, and this was the first eruption of this volcano since the year 1550. So the first eruption of Krasheninnikov in almost 500 years. Now, there's one of the things I was supposed to talk about today was, were there problems with communication, or how were things communicated? And this is at the Global Volcanism Program. We received calls from the press about whether the most recent eruption had happened in 1550 or if it had happened in 1350. And I will be honest and say that whether it had happened in 1550 or 1350 doesn't really matter. If in the case of this eruption response, or in the case of the eruption, the volcano is erupting right now. It doesn't matter if it last erupted 500 years ago or 650 years ago. And this all had to do with confusion about whether the date was reported as a carbon-14 corrected date or an uncalibrated date or a calendar age. And so we were reporting it as one date, and scientists in Kamchatka, who we had gotten the date from, had reported as the other date. It was the same date. So this was some confusion that we had to deal with, and the scientists in Kamchatka also had to deal with. Now, at about 5 hours after that initial eruption, there was a 5 to 6 kilometer tall ash plume that extended 700 or 75 kilometers to the east, and there was ashfall reported in the park nearby. And we'll see a picture of that in a moment, or a map of the park. And the eruption intensity further increased the next day, so that there is now an 8 to 10 kilometer tall plume, which extended 185 kilometers to the east. And for reference, 8 to 10 kilometers is just about exactly the altitude that airplanes are flying at. So this could have caused a potential problem. Now, this is a map of the park right here. We have the inset map shows Kamchatka. That red outlined region there is the Krasheninnikov nature preserve, or the forbidden zone, as it says here. And within this, there's very few people living there. And so as a result, there is very little hazard or very little infrastructure damage, very little damage and threat happening to people on the ground, because there are very few people that live there. There were enough people, however, to report some ashfall happening in this park, in this restricted area. And this is the VAA that Tokyo sent out for that plume. We can see again this black polygon showing the ash dispersal almost due east from Krasheninnikov, and then how that ash is expected to be distributed by the atmosphere, by winds in the stratosphere as it moves along. And here's some photos of it. The ash column there on 3 August rising up very dramatically. The top of the mountain is just below it's probably at about the height of that yellow label that says 3 August Artem Shelder from the Associated Press photographer or credit. And then this eruption transitioned to creating strombolian activity, which is to say lava fountains that we see on the right-hand side that then fed lava flows. And we see that lava flow pouring down the flank of the volcano there. If we look at the volcano afterwards, we can see the photo on the left shows from about a year before the eruption and the earthquake eruption. And then on the photo on the right, we see the aftermath of the eruption. We can see there's these two lava flows extending to the sort of the north or the east-northeast of that northern crater. During the course of this, most of the hazard was being communicated by the KVERT staff through VONAs, or Volcano Observatory Notices to Aviation, and then by the Tokyo VAC using volcanic ash advisories. During this time, so even though the only two volcanoes that supposedly erupted in response to the earthquake were Kluchevskoy and Krasheninnikov, there were other volcanoes erupting in Kamchatka. And so that's important here, that Kamchatka has a lot of volcanoes and lots of them were erupting. So Sheveluch, from about the time of the earthquake for the next 4 months, they issued 90 volcanic ash advisories. Kluchevskoi issued 158 in the 2.5 months from 1 August to 20 October. And this VAA diagram here is from August 5th. Bezimiami, there were 22 issued. Krasheninnikov, on the same August 5th that they issued a Kluchevskoy VAA, Tokyo issued a Krasheninnikov VAA right here. And then Krimsky had numerous VAAs issued as well. And just to illustrate again how much is going on, this is a satellite map that NASA made using their sulfur dioxide imaging products. And you can see from the Tropomi image here, you can see that there are at least 4 different SO2 sources, so 4 active eruptions going on at the same time on August 5th. So there's a lot going on that was happening with these volcanic eruptions. All right, so to sum this all up, there were 4 volcanoes erupting prior to the earthquake. Eruption activity at Kluchevskoy intensified after the earthquake, or possibly moments before the earthquake. The eruption at Krasheninnikov began shortly after the earthquake, about 2.5 days, and it had ash plumes that continued into November. So the earthquake happens, the tsunami happens. This eruptive activity continued for many months afterwards, and it has lava flows that are still active as we speak. The primary volcanic hazard from this activity was ash and its threat upon aviation, and that's because there's relatively minor hazard presented to the small local populations that are on the ground. And all this information was communicated by KVERT issuing VONAs, or Volcano Observatory Notices for Aviation, and the Tokyo VAC issuing volcanic ash advisories. And so to wrap that up, here's a nice picture of Kluchevskoy from a couple days after the eruption. And thank you very much.
Wonderful. Thank you so much, Ben.